This is AQA A-Level Chemistry. We're on the Year 12 topic of bonding, and this is part 3 of the topic. In this section, we're going to revisit the key principles of metallic bonding from GCSE Chemistry. As always, I'm going to recommend that you pause, try the activities as you go, and then once you have tried it, you can see what's gone well and what you might need to develop. So in metallic bonding, we need to know the properties of metals and describe the nature of bonding in a metal. So have a go at the question that's here and then see how you do. So we're told that in ionic compounds, we have outer electrons transferred from metals to non-metals. We've seen that in covalent bonding, we have electrons that are shared between atoms. So what happens to the outer electrons in metallic bonding? And there's a particular key word that we're looking for here. It's something that's absolutely fundamental to the properties of metals that we've come to know very well. And that is that the outermost electrons, the outer principal energy level electrons, are delocalized. Now that means that they can move through the structure. They don't stay with the atom that they were with. So let's move on and let's look at how we can represent the metallic structure. In this case, we're asked to do sodium. You're asked to do a lattice and it includes 8 sodium ions. It's also asking here for an appropriate number of electrons. So the first thing to do when you're asked a question like this is to work out the most logical shape, and I've gone for a 4x2. I've put a plus in the middle of each of them. That means it's +1, which works for sodium. You could alternatively have written Na plus in there. But if you've been asked to do magnesium, you'd have put +2. Aluminium, you would have put +3. Now this particular question also asked for the inclusion of electrons, and more importantly, an appropriate number. Well, if 8 sodium atoms become 8 sodium ions, they've each lost 1 electron. So we would need 8 delocalized electrons through the structure. Okay, let's take a look at some of the properties. Have a go at these questions and see how you do. So, metals are good conductors of electricity. Why is that? Well, it starts with the fact that we have delocalized electrons. And it's what they can do. They can carry charge through the structure. Now, you'll notice that I've highlighted the word through there. That is quite important. It gives an indication of direction of travel once a current has been applied. What about metals having high melting points? We know there are 1 or 2 exceptions to that, but generally they do have high melting points. Well, some of the key words, I'm going to break this right down. Lots of strong. It's the idea that what we're talking about that holds it together is strong, and there are a huge amount of them. But what are they? Well, it's electrostatic forces. We speak about electrostatic forces in ionic bonds as well. But the electrostatic forces are between different things here. In ionic, it's between oppositely charged ions. Here, it's between positive metal ions and delocalized electrons. And because of all of that, lots of energy is needed to overcome them. And then why are metals malleable and ductile? Remember, malleable means it can be bent into shape. Ductile means it can be stretched into wires. Well, it comes down to the fact that metals are regular lattice structures. They're built in regular layers. And because of the regularity, those layers can slide over each other. And that's what allows you to bend or stretch a metal. Okay, we're going to move on and think about this a little bit further now. Specifically considering sodium and aluminium, which of these do you think will have a higher melting point and why? Well, I'm going to start off by drawing out the ions. Sodium forms an ion with a charge of +1. Aluminium +3. We can already see a difference there that's hopefully helping to guide you to the answer. There's another significant difference as well. To form a sodium ion, the sodium has 1 delocalized electron per atom, whereas to get to +3, aluminium has got 3 electrons delocalized per aluminium. So you put both of those together, and what you've hopefully led to in your answer is that aluminium has a higher melting point. 1, because there's a higher charge on the ion. Now that higher positive charge makes it more attractive to delocalized electrons. It makes the attraction stronger. But also, if there are more delocalized electrons per atom in aluminium, that also increases the attraction between the nucleus and the delocalized electrons. So let's move on and look at which would be a better conductor of electricity, sodium or aluminium. Now we're going to use some of the same key ideas here. It's aluminium, and each aluminium atom will have 3 delocalized electrons. So there are more electrons delocalized per atom. And if there's more electrons that are flowing through, that means more charge can be carried through the structure. Okay, that takes us to the end of this video. Thank you for listening.